Hi, everyone. So my name is Tom Manville. I'm VP of Engineering for Kasten by Veeam. My team builds essentially all of the K10 product, as well as a few open source projects as well. I really like this format. I do want to have some engagement, push back, call me out if you think I'm saying things are wrong.
You're wrong.
Yeah, thank you. Appreciate it.
That's done.
So I think what I want to do with this talk is just go through the things that what we see with customers and then figure out how that impacts the design. I think there's a lot of debate already so far, even on the way that we deploy our product, how we configure things, and how we address different customer use cases. Let's see if this works. There we go. I like to show this slide to start with, just to give a sense of the ecosystem. Every time I read the slide, it actually gets more and more difficult to read. So you look here, I can't read anything on here at this point. Bonus points if you can find Kasten.
Well, you'll be in that second one down, which is all the storage and data protection, isn't it? Second
right.
Down.
I heard of an NASCAR slide, but
I think the key takeaway from this slide that I want to convey is that when we talk to customers, it's a very varied environment, right? Big customers will have many of these projects, maybe a few of them. They'll have their own bespoke tools that they need to use to deploy their apps. And really, as a backup data protection product, we have to go and support all those use cases, no matter what cluster setup they have, no matter what kind of deployment models and other tooling they have around their systems. The other thing that's important to convey is that the community is moving pretty quickly on data protection. So this is actually a slide that was pulled from the data protection working group in Kubernetes. And this is kind of the effort that the community is going through to give the primitives you need to go be able to back up your applications. The state of the world is that right now only really volume snapshots and some work on workload APIs are kind of complete in the community. Everything else is either work in progress or kind of planned for the future. And this slide doesn't even capture things like CBT, change block tracking, like incremental backups and that kind of thing. What we've done at Kasten is actually we've gone and implemented a lot of the things that are missing, while still being able to consume all the interfaces provided by the Kubernetes ecosystem. So everything here that is essentially not green is something that our product can provide, both doing native integrates with applications, as well as kind of moving data around and providing really robust backups. So before I jump into kind of more nitty-gritty details of what we see in the K10 philosophy, I just want to give a brief overview of what K10 looks like and kind of what we support. So because we're an application you install inside your cluster, and that can be in many clusters if you have many clusters that you want to protect. Because we're a Kubernetes application, we can actually support any type of distribution you have. So in a bit we'll get into more advanced use cases around kind of moving between different distributions, which there was a question on earlier. But it lets us do things like support different marketplaces. Something we actually just implemented last Friday, we just released it, was the OpenShift Marketplace transactability. So customers can go to their OpenShift Marketplace and download and use K10 and pay through entirely the OpenShift Marketplace. And another interesting thing is what we're seeing right now is kind of everyone's moving in different directions. So OpenShift we see moving to cloud providers with things like Arrow, they're offering in Azure and Rosa. We also see cloud providers moving to on-prem as well with things like EKS Anywhere, which we are one of the opening partners with, which was pretty exciting for us. So the design principles I want to consider when we go through this, because I know SaaS is going to come up for sure. We're an application deployed in the cluster, and there's some reasons that I want to talk about for that. I know that there's going to be a lot of discussion and it'll be ongoing on SaaS. I would say that I think based on the customers we're seeing, that our deployment model makes a lot of sense. I'm especially excited about kind of copying the Veeam model of deploying through managed service providers. As Michael Cade mentioned, there's lots of managed service providers that Veeam is partnered with. And I think using that same model for Kasten makes a lot of sense, especially given the fact that we're a little bit tied to our deployment model here. Given that we see so many different types of environments, we see people who are using different types of systems, right? So many people will be deploying their own Prometheus instances or Grafana instances. And so the philosophy that we've taken in K10 is that we really want to implement all the primitives and support a fully functioning system by default, but we can then go integrate with external systems like your instance of Prometheus and Grafana that you have the operational experience around that you can go run yourself. That's not only true for things like the operational aspect of things, but also the infrastructure. So your storage, right? We're completely storage agnostic. You can use whatever storage you want. We have even integrations that go beyond just CSI. We can have custom direct storage integrations as well. What's been kind of fun as we develop K10 is actually that we've kind of grown up with the ecosystem a little bit, right? We started Kasten in 2017, and at the time, not many people were actually running their stateful applications inside Kubernetes. What's changed since then is that people are definitely running their stateful applications in there, and they're getting just more and more complex. And so when K10 understands an application, we take the same philosophy that we do with the rest of the ecosystem integrations, where we try to understand what's going on, but then if we need kind of a fallback, we can rely on your infrastructure or even user input to figure out what to go do. A big selling point of K10 is actually the native API integration. This is actually the basis for most of our cloud and our cloud native ecosystem integrations. We do some pretty cool stuff with our APIs. You know, we just saw a demo on the Vault APIs. And what I want to point out with those is that we actually implemented aggregate APIs around those. So the easiest way to implement an API is in Kubernetes is through a CRD, custom resource definition. But because we actually went and used a more direct integration with the Kubernetes API system, we have more control over how these keys get managed. So you were able to see a full key rotation for encrypting the master key. And that key rotation process actually has a lot of restrictions around it, right? So first off, it's not going to be backed by the etcd cluster. It's backed by something else in the catalog. It can be backed by something in Vault, for example. It also has protections, so you can't go and delete a key that's in use, for example, which is very important. Otherwise, you wouldn't be able to decrypt any of your backups. And we actually have this type of innovation across all of our APIs, right? So we have actions that you have a very large scale, so they don't make sense to put in the etcd cluster, and they have a specific life cycle that we want to update as time goes on. You know, we have applications that give you detailed views on all of your different an applications API that gives you detailed views on all of your apps and namespaces you have. And then we have several other things around configuration, around reporting. So we will be supporting more advanced reports in the future, including different integrations with Mail. But that's coming up pretty soon. Because we have implemented K10 in a way that uses all of these different APIs, we were able to support different types of authorization and authentication domains. So you actually have already seen two examples of us logging in using a token, but also through OIDC. In this case, it was Okta. But because we're very cloud native, you can essentially use that authentication token to do anything that a user using kubectl would be able to go do. You know, we also have direct integration with OpenShift authentication. So if you want to do your user management through the OpenShift interface, that's great, as well as Active Directory, and of course, what we call basic auth, or really HT password. Authorization is actually a really interesting topic. You know, we can spend a lot of time on this. There's you know, the core tenet of being built on Kubernetes APIs lets us directly integrate with the Kubernetes RBAC system, which is kind of the basis for all of the granularity of RBAC we have on our own APIs. The philosophy is that we have that base layer, which gives you fine-grained permissions around our APIs. But then on top of that, we build default roles and cluster roles. And so you can imagine different users, maybe you want to have access to a specific namespace, right? Kind of a basic user. You can imagine admins that want to have access to be able to back and restore all of your data. And this gets really interesting when you talk about managed service providers, right? Because if a managed service provider is going to provide a SaaS platform, you need really strong multi-tenancy. And because we have very fine-grained permissions, you can actually build exactly the roles that you want around those permissions and use native Kubernetes APIs to do that. In addition to the basic levels of just the Kubernetes RBAC, we actually have help for multi-cluster users. So if I have permissions in one cluster, I can then transmit those permissions to other clusters as well. That lets you essentially manage you know, different authorization domains just using the K10 interface. So it's actually an add-on on top of the native Kubernetes support. I'll stop there and ask if there's any questions. Is this interesting? Does this make sense?
You know, I think it makes sense, but this goes to kind of my earlier comment where did the whole, compared to Veeam, where is waiting on kind of Kubernetes maturity hold data protection and data management back? Like, I get that you guys are K8 compliant, but that comes at a cost. So what shouldn't I expect to see that I would expect as a Veeam customer coming over to, I get the warm fuzzies that is K8 compliant, but I come to Veeam for simplicity overall. And one of the things we absolutely got from today is that data management in Kubernetes is not simple.
Yeah, I think I can give a lot of specific examples of what I think the Kubernetes community is missing. You know, so one example would be replication. You know, we'd already discussed if I'm in AWS, I can automatically set up a migration of an EBS volume snapshot to another region. That actually is not something I can do through the CSI interface. You know, I have to kind of go out of band and then go do that copy. So K10 supports that directly. It's a bit of a pain, to be honest, for us to go implement that for every different storage provider. And there's kind of a proposal in the community which has been floated to actually support that. I think it was proposed by Red Hat to support managing replication through CSI for different types of volumes. And so I think there's a lot of innovation like that that's going on that we're really excited for. The community isn't quite there yet, so actually we have to go and implement these direct integrations that will do copies. You know, and Veeam is like VBR is a great example of things that you know, can do things very efficiently. So you can do instant restores, I think they're called, right? Fast restores. And supporting things like that in Kubernetes is something that we have to go tackle on an individual case-by-case basis, but we're very excited for the community to come and build all that up and help support that.
Do you guys have customers that like approaching this in a hybrid manner, like just, they're, for lack of a better word, cheating and using Veeam to do data replication and then hacking together a solution after the fact?
Yeah, I think the image-based backup, and we've said that story quite a number of times, is that image-based backup, you're going to lose a lot of the granularity and the functionality with that. I'd hope that because we've got Kasten, and Kasten has even a free tier that is considerable as well, that can help like up to 10 worker nodes, right? So I'd hope that would steer people towards that versus using a below par image-based backup for a Kubernetes cluster. But I haven't spoke to anyone that said, no, I'm going to use Veeam to do it. But I guess they could be, right?
I don't want to, provoke here or whatever, but so looking at the status of Kubernetes in terms of storage and protection and everything, isn't it better to, simplify everything and, having a single layer that manages everything for me when it comes to storage, including protection? So I want the storage layer and the protection layer integrated in a single product, so I can do everything that I can do with my enterprise storage.
I'll tell you why you wouldn't want to do that, because if you've got clusters in multiple locations, you'll have different storage paradigms that all have and could.
Well, you pay for the layer on every single cluster.
You mean you want to do the storage layer across multiple locations and multiple platforms?
Well, for you, the applications are critical, so that the infrastructure part is a minimal part of all the things that you have on top of it. I mean, so it's not the cost of Kubernetes, the infrastructure, it's cost of the application, and 1 hour of that application stop it because
I can see what you're saying.
That's cost me much more than having a snapshot every hour or every day, because I have to move too many gigabytes of file.
Yeah, I agree, Enrico. A lot of the frustration I have around Kubernetes and this sort of stuff is it really feels like the early days of VMware, when backing up an application when it was in a VM was horrific. Because VMs were great, but we had to throw away all of the infrastructure stuff that we'd built up for a decade or two. And it really does feel like we're doing exactly the same thing here with containers and Kubernetes. And I wonder, maybe, Kasten, you can give us some ideas of where customers are going. Are we going to get to the point where it's just you're going to plug into all of the APIs on the storage arrays and do snapshots on the storage array level, do replication at the storage array level, or are we really moving everything into a software abstraction and everything goes through the CSI?
I think it's a great question. My thinking here is that, first off, there's a big variety of different storage providers out there. But I think the point that the most efficient way to move data in many cases is actually by using the storage, letting the storage handle replication, for example. And so our philosophy, in some cases, in this case specifically, I guess, is that we support, we actually have the ability to do this, to let you replicate your storage kind of under the covers, and then rebuild the Kubernetes primitives on top of that. And so that's, right now we actually do that through kind of more of a side process, which is through our extension mechanisms, through Canister specifically. But actually, we are scoping out building that as kind of a native part of the product as well. Our customers tend to have a variety of storage instances, right? Big customers especially will be very varied. And we don't see, for example, one type of storage deployed at many customers. But I think it's definitely great points. There are many instances of things that feel quite early within the Kubernetes community, definitely. I wanted to give a cool example of something that you can get for free because of the way we set up APIs. Not really directly related to storage, but related to our management of us. It's very easy to set up auditing on all of our APIs. So you can go see exactly who's accessing keys, who's creating backups, who's creating policies and that kind of thing, just completely out of the box using Kubernetes auditing. And then, of course, you can extend that by plugging into one of the many cloud native systems that will let you aggregate and collect and analyze those logs. I want to talk a little bit about failure domains, because this is actually one of the key points that we discussed when we talk about why we deploy in cluster. So this is the only Creative Commons picture I can get of this, but there's a lot of container ships out there that people have pictures of, so you might recognize this one. And when I talk about failure domains, I think the first thing that comes up is discussing this 3-2-1 backup strategy, right? You see this a lot, which is pretty common. You want 3 backups of your data on 2 different storage mediums, and one of them should be offsite. And I really want to talk about the spirit of what this means and the philosophy behind this. And when I internalize this, I actually think about it as kind of, you want to mirror your infrastructure with your backup strategy. So if I do a failover to a new cluster, I better make sure that my backups are accessible or even inside that cluster. And when I think about that in the Kubernetes context, I really think about that as doing replication or doing backup or store into another cluster that's already around. So when we see very advanced, complex use cases with many multi-clusters, things like edge use cases and air-gapped use cases, we want to make sure that we mirror the backup strategy to that customer's infrastructure. And by deploying into a cluster, we actually have the ability to do that because we can be wherever their cluster is. And the high level of failure domains is many things can fail, right, as we know. And in my opinion, you want the ability to kind of do a failover at every level of the failure domain. We'll skip ahead a little bit just because we're short on time. One thing that's pretty common, I'd say probably around 1/3 of our big enterprise customers deploying air-gapped modes. This makes it a big challenge if you're going to do something like run as a SaaS platform, unless you have a managed service provider who can go in there and really help you run your SaaS that's tailored to your infrastructure. So K10 fully supports this. You do have to manage your own images because, if you don't have access to pull down images from the outside world, we have to do a copy for you to get that into your infrastructure. And once you're inside this air-gapped environment, we tend to see backups and things want to remain within that air-gapped environment. So pulling data out from that is a big challenge. An air-gapped is probably the extreme case, but there's also other cases, even just around egress costs, right? If I have a multi-cloud strategy, I have an on-prem public cloud strategy, moving data between different domains is actually pretty expensive. And in many cases, you may want to, yeah, that's definitely an understatement.
No. Well, Mike knows why I'm laughing.
Oh. Yeah. And so it's pretty important to make sure that you can keep your data in the domains that follow your data protection strategy. We see many different kind of indications of edge clusters. So, you know, one of my favorite ones is in retail, where people are deploying one cluster for each of their retail stores. You know, and that's a pretty interesting model. There's other models where people just have a very distributed network, right? And they want to have clusters kind of all over the place that are local to whatever region they're in. And we've kind of internalized a few principles from Edge that we've brought into K10. So the first one is that disconnects are pretty common, right? You want to be able to operate entirely within a cluster without needing access to the outside world. This is kind of similar to the air gap use case. We also see very constrained resources. So what that means for us is, you know, we have a product that can deploy with many different things, right? We mentioned like Grafana, Prometheus, Audit, and all these different things. For us, that means giving people the option to actually scale down what K10 is doing. So both in terms of the resources you spend on doing your backups, so things like throttling, but also in terms of what you actually go deploy as part of K10. So for example, removing Prometheus, you know, using centralized Prometheus only and directly instead of using the one deployed by default in K10. And then of course, the big thing with edge clusters is actually multi-cluster management.
Veeam is a parent company that has a range of products that do data protection across a number of environments.
Definitely.
Then you've got your K10 environment, which is sitting within a cluster. And then you've got the ability to now back up stuff that's not in the cluster, but bring it into that cluster. And I just wonder when you're going to try and bring it all together so that you've got this integration that allows you to see where your data is, regardless of which platform it's on, and not have to think, I've got different products. And personally, I think running data protection within the cluster and leaving it in the cluster might be a long-term challenge. I'm not saying you shouldn't necessarily have components sitting in the cluster that pull that data out on your behalf, you know, but I think that because a cluster isn't necessarily going to be a long-lived item, rebuilding it every time and putting backup into it and storage into it every single time you want to rebuild it becomes arduous. So I'm interested to understand where you think the strategy will go with how you bring all your products together.
Yeah, those are, I consider that kind of two good questions. The first question I think is kind of what's the global strategy with integration with Veeam? You know, actually, we'll probably take that one offline, I would ask. The second one I think is also a fair point, which is that we really want to make sure that K10's lifecycle can match the lifecycle of your cluster, right? So you describe an agent inside the cluster. You know, if you can scale down K10 to be just an agent, I think that would kind of satisfy that use case and make sure that when you deploy your clusters, that you automatically have the hooks to go deploy K10 like you'd have any other component of your app. And you know, I think what we're building towards is that vision, because that is definitely a very valid use case. We also are still going to support massive clusters that are long-lived, you know, like the 300, 500 node, 600 node clusters, and one is the K10 for that. But I definitely think it is a valid use case to have very small, short-lived clusters, right? You know, 3 nodes. These edge use cases, being able to scale down the resources that K10 consumes, being able to scale down the overhead of deployment is definitely very important. You know, we do a pretty good job. We're not perfect there. You know, I think the enhancements we're making to multi-cluster and the ability to scale down would definitely help with that.
Okay, let me rephrase that question, sorry, Keith, slightly differently. Sure. And say, if you look back historically, if we look at, say, a VMware environment, rarely did you change the software unless a big release came along. So it wouldn't be like every quarter, every 3 months, you'd say, oh, a new one's out, upgrade, upgrade, upgrade. The flexibility, the benefit of Kubernetes is you can do exactly that. You can rebuild a cluster every single, you know, quarter, every single month if a new update comes out. You've got to somehow keep up with that. And you've got to keep the compatibility and the consistency and the backward compatibility. So that's why I think putting everything in a cluster becomes a bit more of a challenge, because you've now got tons to support on so many different cluster levels and so many different environments and so many different features that get deprecated and added and taken away and, you know, whatever. That's the logic for that.
So I guess to add to that, and a little bit of pushback on that is, that's kind of Kubernetes. I mean, that is the operating model.
Yeah.
So when I'm thinking about, we have a back channel going on about networking is so much like this in Kubernetes that if I'm deploying NSX, I have to deploy components of my NSX inside of my cluster every time I build the cluster. And that's not the only thing. All of this overhead that I have to put in my Helm deployment for every time I deploy a new cluster. So the question is, do you go against the grain and do what we've always done that has worked for us over the past 30, 40 years? Or do we conform to this adopt this new model of operating in this cloud native thing? And it's, I think for us, or I'll speak for me, it's frustrating to have to, kind of redo what we've perfected. I've tweeted out that we're recreating storage replication yet again. So,
yeah, I think this is actually a broader problem than just data protection.
I think I agree with you. I don't think this is a your fault problem. I think this is where the environment's evolved and the speed that's evolved. You're trying to catch up and keep going with it whilst the standards and the direction are changing.
I've seen people, so it's definitely a challenge. I've seen people, make progress towards solving it for themselves individually. I would love to have a global solution to it, but my kind of opinion is that people are going to have to solve this because no matter what, it will be a problem. And so if we're able to be deployed as any other application in your cluster, then we kind of can piggyback on that, just like we do for many other things, right? The metrics, the monitoring, APIs, all of that. So, but I agree. The challenge is definitely there. We're pitching new open source projects, so that might be a good category for stuff there. So, thank you.